right, good afternoon, everyone. Certainly hope you all had an excellent weekend. So I'm going to go ahead and apologize in advance. They're doing some construction behind the classroom today. They're putting in some sort of outdoor seating area for Union. So you might hear some construction noises. I guess that's the one good thing about using a built-in laptop microphone is it doesn't pick up a whole lot of stuff other than what's directly in front of it. That might work out for the better today. But there's some bulldozers going, so I'm going to go ahead and apologize for that. Also, I'm not going to apologize for this, of course, but there is homework posted for Chapter 8. It's just one problem. Make sure that you submit it by the deadline, which is this coming Sunday at 11:59 p.m. So you have just under 1 week to do that. It shouldn't be too tough. Basically, you're just putting something in first, second, and third normal form, submitting it. You'll be good to go. And then also, I want to go ahead and mention this. Next class, if you look at the schedule, we're doing the project introduction. So I've already sent out well, I haven't sent it out yet, but I've delayed response. So tomorrow at 1, you should get some additional information about it. I'm pretty sure I already posted all the stuff in Canvas, but I do encourage you to attend that in person, unless you're unable to for whatever reason. At the minimum, I encourage you to email your teammates and just kind of see what their plans are for how exactly you all want to collaborate. If you all want to meet in person, that's perfectly cool. If you all want to meet virtually, as long as you all work that out, and it doesn't really matter to me how you all do it. But I will send out that information, I believe, at 1 p.m. tomorrow. Could be 1:30. Don't remember exactly what I set it to. But certainly be on the lookout for that. So like I say, all the project will cover next class. Any questions before we begin the content for today? Like I said, certainly feel free, especially on a day like today, to jump in with any questions if you have them. I also encourage participation, of course. But for now, I'm just going to go ahead and jump into everything. So last class, we talked about normalization, and we talked about the different forms of normalization. We talked specifically about first, second, and third normal form. And there's some key distinctions between each of those. So when we have first normal form, we actually have a usable database. Each and every value inside of there is atomic. What atomic means when we're talking about the context of a database is that each attribute and each specific record only has one and only one value inside of it. So we don't have a case where we have something like item 1, item 2, item 3, item 4, and so on, because a lot of times we're not going to have a record inside of those for a specific instance. So we want to avoid that problem. So how can we do that? Well, we could certainly use associative entities. If we wanted to kind of avoid having the case where we have item, X, class X, account X, whatever the case is, we don't want to have more than one variable associated with that. Instead, we would rather have another associative entity where we put the information from the customer. We've taken the information from the item, and then we tie that all together through our join statements and other statements like that. So that's really the principle behind this, is that we're trying to kind of determine a way that we can have no repeated information. We also don't want to have a variable that a substantial portion of it is null. So we're trying to balance out those two things. So that's first normal form. Each of the values are atomic, and we don't have values where a good number of them are null. Then we'll move to second normal form. This is where we're saying that each of the values inside of it don't just depend on part of the primary key, they depend on the entirety of the primary key. So if we had a table, let's just use this example here. If we had customer account, you see I have this ERD for, I believe this is a bank, and we had customer account pulled up here. Imagine if we put the customer's credit score inside of this customer account. That's a violation of second normal form because customer account is not affected by the account number. It's only affected by the customer. So you can certainly imagine a case in which we had an account that was held by two people. One of them had very good credit, one of them had very poor credit. We can't have a case where we're going to have that information because it's not relevant to the account. The account doesn't determine it, so in that case, we cannot have that in second normal form. It's not a violation of first normal form, though. So that's what we're talking about, is that each of the columns depend on the entirety of the key, not just part of the key inside a second normal form. And then when we move into third normal form, we're not just looking at the key, we're looking at columns depending on other columns. So imagine if I had inside of the customer entity, imagine I had something like social security number inside the customer entity. That depends solely upon the customer ID. Two people don't have the same social security number. Now, I know the book gives a couple examples where maybe two people do have the same social security number. We can just assume that's not very likely. So social security number is unique. It's a candidate key. We don't have that inside a third normal form. So we would have to figure out some other way we could store that information and remain inside a third normal form. Now, I will say this. In a lot of cases, second and third normal form may be the exact same. Particularly, we think about what are entities that are likely to have composite keys. So there could be several examples of that. I would say probably one of the most common examples of that is going to be an associative entity. And when we think about why that is, well, associative entities are, in a way, they're the combination of several entities. Not directly, but certainly in an indirect fashion, we're combining attributes of several entities, putting them into an associative entity. So in most cases, that's going to be where you're going to see the differences between second and third normal form is inside of those associative entities. Outside of them, you're probably not going to see a huge difference. Also, in most cases, you're not going to necessarily see a lot of columns inside of an associative entity in the first place. It's just best practice to put them elsewhere. So if you want to have information about the customer, you put it inside the customer table. You want to have information about the account, you put it inside the account table. For the most part, it doesn't make sense to put the information inside of the customer account table because it's not relevant to the entirety of the two primary keys there, so the composite key. Any questions so far? That logic kind of makes sense? All right. Well, let's go ahead and do some examples of this. And, you know, in a normal semester, I'd probably be writing on the board or using the document camera, but unfortunately, I don't have a great way to share either of those. So Word it is. Let's go ahead and make this large enough for everyone to see. I'm just going to use size 20 font. Should be a reasonable balance, I think. So let's go ahead and just start off with first normal form. So imagine I wanted to create a table that could handle customer orders. So right off the bat, we're just going to make this in first normal form. What does that mean if it's in first normal form? Am I going to have a lot of different tables or probably just one, maybe two tables? I think Jarek's exactly correct. It's probably going to be inside of one, maybe two tables at most. So now we're going to think about what do we need to know about the customer? Well, we need to know cust f name, cust l name. What else? So we could certainly know things like credit card number somewhere if we're going to have an account for a customer. Obviously, we'd want to make sure we're encrypting this database, but that's standard practice. We don't have to worry too much about that for this. Maybe customer credit score. Maybe we need to know that. Looks like we got some stuff in chat. Let me switch over to that real fast. Yeah, we probably would need to know the CVV for the credit card. You know, got to be able to bill it, of course. So then we'd also need to know stuff about the order. So, you know, the customer's going to order something. What are they going to order? They're going to order stuff. So we need to know the order number. We need to know the item inside the order. We need to know the quantity. You know, in this case, what we're going to assume is that if a customer orders multiple items, so they order item number 1 and item number 25, we're going to have two different instances of this database, or not the database, but the table. So we're going to see two records if they order two items. If they order 3 different items, we're going to see 3 different records. Certainly not the most efficient way to do things, but that's kind of the point of normalization. Is we want to make it more efficient. So we've got item number. Let's put item description. Anything else we need to include here? Well, let's ask the question, is this first normal form? Certainly all atomic values. There's nothing in here that's multi-valued. You know, I don't have an address. And if I put in an address, let's just say I put in an address column here. Now this isn't first normal form because address is not going to be atomic. There's going to be several different fields inside of address. So if I wanted to include address, I'd do something like street, city, zip, you know, all that sort of stuff. We're not going to bother. We're just going to leave it as is. This is in first normal form. So let's go ahead and make a note of this up here. And this is one example of how we can do first normal form. But what's the problem with this? That's exactly right, Maxwell. So if we have multiple orders, or even if we have multiple items inside of an order, we're going to have quite a bit of redundancy. You know, imagine a case where we're Walmart. And imagine for every item you buy at Walmart, we have a new thing where we're storing all this. It's going to be tremendous amounts of waste. Do we like waste? I'm hoping the answer to that is no. So we certainly would want to avoid that. So when we do that inside of normalization, what's our main tool? What's the main thing we can do? We can break it up. So basically all we have to do is just break this into tables. So as we move to second normal form, we're going to make new tables. So it looks like we got a question. Would item weight be included for creating a shipping label? We certainly could. You know, we don't have to include it, but we certainly can. If we're going to be shipping it, probably we need to know the weight. So let's go ahead and think about how we can break this up. So we have information about the customer. We have information about the order. We have information about the item. Now, what does that tell us? We have information about those 3 things. What can we do from here? Okay, and a customer table and an item table. I think Jarek's got a great point there. So let me think about how I want to do this. I'll try using columns. This probably won't work out too well. That's okay. Let's see here. It would have made a lot more sense for me to do this in Excel, but let's go ahead and move it over to Excel. I think Excel will just work better for what we're doing. Sorry about that, guys. All right, so I'm just going to make a new, just make this a lot larger. All right. Might have been a little bit too large on the font, so I'll just shrink it down. Okay, can everyone see this okay? I certainly hope so. If not, let me know. I can adjust it slightly. So now it's important that we kind of consider making different tables like Jarek said. So for second normal form, we're going to do just that. So we're going to start off with a customer table. Then we're also going to come down. We're going to make an order table. And let's make an item table. So for customer, we can be a little bit lazy here, I think. We're just going to copy this, these attributes from the first normal form. Certainly cool for us to do. And I'm going to go ahead and bold these table names. There we go. And for order, you know, we know the order number. and we'll come back to that. And then lastly, for item, we have information about the item. So there's some problems here. Let's go ahead and address them. So looking at the customer table, what's a problem with the customer table? So we're missing something kind of important. So we need some sort of unique identifier. We're just going to use customer ID like Derek suggested. But we need to have some sort of primary key. So for the primary key, I'm going to underline it. Then for the order number, we can assume that's a primary key. Certainly think that is fair to do. And then for item, let's just use item as the primary key. Because if we have a table full of items, each of the items should be unique. Otherwise, why would we have it? So I think that's pretty logical. So far we have information about our customer. We have information about the item. What are we missing? We need to have some sort of associative entity that will take information from the customer table, and it's going to take information from the item table. And in fact, we also want to remove the quantity. Why do we want to remove the quantity from the item table? It's not relevant to the item itself, because if we have, an item, we don't necessarily know how many each person is going to order. There's no limit to saying, let's say we're a pizza place, and we have the item is pizza. So we have a pepperoni pizza. Is everyone going to order 2 pepperoni pizzas? They're not. So the item, we're actually going to put inside the order. And we're also going to put the customer ID. And we want to also put the quantity. So the quantity of the item that they ordered. So if I can figure out how to insert, whoops, that's why I can't insert. So we want to get the quantity here. And again, the reason is because the quantity is relevant to the specific order that we're in. So in this case, it is important that we have the order number still be unique. Why is that? Why are we not making item and customer ID the primary keys? Why is order number going to be and in fact, we do have to make both of them primary keys as well. But why are we having order number be a primary key? It is unique. So if we have an order, and let's say we're a pizza place, and you order 2 pepperoni pizzas. What if you want mozzarella sticks? Do you deliver them separately or do you deliver them together? It's the same order. So we want to make sure that we include them inside of the same thing. However, we want to make sure that the item value is atomic. We don't want to have the item have multiple values inside of it. So to do that, we're actually just going to have multiple instances of this associative entity. So in this case, we're having order serve as that associative entity, where we're going to have multiple instances of order for one order. At least we can. You can only order 2 pepperoni pizzas if you want. Nothing wrong with that. But we want to give our customers the option to order other things with their order. Does that make sense so far? All right. So, right off the bat, we have this in second normal form. Now let's go through to make sure that each of the attributes inside of here only respond to the entire primary key. So customer first name, last name, credit card, CVV, credit score, those all relate to only customer ID. Then we have item weight and item description. Those only relate to the item. Now here's where it's going to get a little bit interesting. We have order number and customer ID. Does quantity relate to the entirety of those? So you could actually make an argument here that it does, and here's why. Because quantity is not necessarily about the customer, but at the same time, we think about these as being a unique sort of attribute to where they're single-handedly kind of forming a primary key And in this case, we could make an argument that quantity only relates to order number, that only relates to item. But we can assume in this specific instance that it does relate to other. Now, this would be a case where if we had something like a, imagine we had some variable for customer inside of order, then we'd have a problem. So if we had the customer first name and customer ID, that's going to be a problem. Now, that's going to be a problem because we already have the ability to get the customer, any information about the customer, using the customer ID. So if we had address stored in here, and we had all the different attributes associated with address, we wouldn't have to worry about accessing that address because we could use the customer ID to make the queries, make the join statements. So in this case, we're going to be all right. So does that make sense to everyone? All right. And then, so we've already gone through this. Now, is third normal form going to be any different in this case? There is going to be one difference. I'm going to call it third normal form instead of second. But, look at this. I mean, so we have customer first name, customer last name. Those don't depend on each other. Certainly if we have credit card, that doesn't necessarily depend on customer ID. It could. So how could we handle this? Should we remove credit card? We don't necessarily need to. Customer credit score. Now, again, if we're having multiple instances of the customer entity, then we would absolutely remove both, certainly remove credit score. But we're not necessarily assuming that at this stage. So basically, first name alone is not unique. If first name were unique, then it would be a problem because it would be a candidate key. So what we're really looking for is there something else inside of this table that could serve as a primary key? And, credit card potentially, but can people share a credit card? They can. So I can make an argument that credit card is not unique. Credit score is certainly not unique. Can people have the same credit score? Yeah, I mean, we have what, 300 million, 350 million or so people in the United States. It's certainly a fair assumption that multiple people share the same credit score when there's, going to be a substantial number of people. If there's only, let's say, what's the lowest credit score you can get? Is it 450? 250? Let's just say there's 850 possible credit scores and 350 million people. It's impossible for credit scores to be unique. Let's just kind of leave it at that there. Then, is quantity going to be unique? No, certainly not. Multiple people are going to order 2 pizzas over the lifespan of a firm. Then we have item weight. Could potentially be unique, but unlikely. Item description, that's certainly going to be unique to an item. If we have one item, what's going to differentiate the item? What it is. So if we have let's just say, pepperoni pizza, what will be the item description of pepperoni pizza? A pizza with cheese, mozzarella, and pepperoni. And dough, of course. Yeah, so some sort of marinara, something like that. We're going to have that information. So we could actually remove item description if we chose to. So it's pretty much how I'd go through third normal form. All we're doing is we're making sure there's no candidate keys. So there's nothing else that's going to depend on something else. So the book uses an example there for, I think, third normal form, where they take information about the country, and then they don't want to have information about the exchange rate as another. And so what they have, actually, is they have the country code, then they have the abbreviation for the country. And then because the abbreviation determines the country code, then if we have other information like the exchange rate for that country, we're going to run into an issue where we kind of have that transitive dependency that we want to eliminate that. So if we had that problem, we could actually just make another table where we would have only 2 different values inside of it. Is that practical to do? is it practical to make another table and remove the item description? Is that a good thing? Yeah, pretty much. So it doesn't really bias a whole lot. So I would say as long as you're minimizing your redundancy, you're going to be all right. But certainly you could approach this from a lot of different perspectives. So that's why I kind of suggest you look at the ERD, you find problems with it, you build another ERD, you make tweaks to it, of course. You don't have to just trash the whole thing and start from the beginning. And you kind of go through that iteratively. Is that a better approach than doing the first, second, third normal form? Could be, could not be. I mean, it depends on how you sort of view these, but basically, we're going to get to the same point. That's the thing I wanted to communicate today, is that whenever we're doing this process, if I were to say, let's build an ERD, we're going to have a customer, we're going to have an order, and we're going to have an item. Each of those are going to be tables inside the ERD. So, then we're also going to get the atomic attributes for each of those. So that's pretty much the main thing I want to communicate today. Any questions so far? You guys want me to do another one, or you guys want to call it a day? Yeah. Yeah, so basically in a third normal form, you're looking for any candidate key. So, like I said, the book gives the example. They have some sort of country variable, and then they have the either country name or country code. And because those are basically doing the same exact thing, they have other variables inside the table that depend upon, or they can be uniquely identified, rather, with the country code. So that's a violation of third normal form. Should you, in best practice of building a database, should you care about that? You certainly could. In some ways, you would be repeating information, but this is all about balance. So if you have a database and you have 1 million records and you have 1 million times you're repeating one variable, that could cost you some storage, and it could also cost you some processing. It's going to take a lot of resources to process 1 million additional records that you wouldn't otherwise have to worry about. But if you're in a small database, you have maybe 200 countries, I would say you're going to spend a lot more time working around that to get to third normal form than you would if you just included it and you had a slight violation for third normal form. Does that make sense to everyone? So that's really the kind of the meat of today. If no one else has anything they want to ask, or if you guys want me to do another one, I'm certainly happy to. But apart from that, you guys are certainly free to go. Let me make note, though. Next class, I do encourage everyone to attend face-to-face if possible. We're going to be going through the project. I think it's probably good to meet with your team. I'll probably talk for maybe 10, 15 minutes or so, just to introduce what the project is, go through the rubric, go through my expectations for the project, and certainly I'm happy to answer any questions, but I do think it's important that you meet with your team and you determine which team member wants to do which task, and maybe 2 team members work together on. I don't care how you divide it up. The only thing is that you submit the project and you submit it on time. That's what I'm grading you on. You work together however you want. But I do encourage you to, at minimum, talk to your teammates, see what their preferences are, see how you can communicate with them. I hope that most of you have probably reached out to them before. Like I said, if not, certainly it's always good to send an email and just see what everyone's preference is. So that's really all I have for today. I hope you all have a great day. I'll see you all next class.